And this is 2014, and you've got the Ebola outbreak raging in West Africa, and you've got the question of how, which is a similar question to COVID. The symptoms are so similar to your daily problems. How do you differentiate? And so the idea then became, let's make a lateral flow test for Ebola diagnosis. But at the core of the test, instead of using antibodies, which is what used to pick up the Ebola virus or whatever the antibody of interest is, let's use what are called aptamers. Aptamers are single-stranded DNA. The attraction for aptamers was that aptamers are much easier to make than antibodies. An honors student, a master's student in a normal lab can make them, which is very different to antibodies, which are more expensive to make. So I made my aptamers, 4 of them against the Ebola virus, determined how well they worked, wanted to make a lateral flow test out of them, was unable to because of time constraints, submitted the masters, but stayed with the idea of aptamers because although they're easy to make, on the other end, they are single-stranded DNA, so which means you can reliably make them and there's no batch-to-batch variation. And then the second thing is that they are a lot more stable than antibodies because they're not proteins. And that's what the idea then became. The question was, can we develop a company that uses aptamers to make lateral flow devices for anything? And that's what the focus of the MBA was for me. Use the MBA to develop a company that does that. So that's 2016, 2017.
Fantastic. Speaking of the company, what diseases have you targeted so far? Have you guys already successfully produced diagnostic tests? And to what diseases, for example?
So it turns out there's a reason why Aptamer lateral flow devices aren't on the market yet. It's not just an oversight of people in the field. The challenge is when you're making a lateral flow test, the end result is a sandwich on the test line. What we see as a line is actually a sandwich, and what I mean by sandwich is there's an antibody that's immobilized on the nitrocellulose. There's a target of interest, right? There's a target of interest, and then after that, there's another antibody.
Yes.
So that's your sandwich. But the last thing is there are gold nanoparticles attached to this detector antibody. Now, what happens is that if these gold nanoparticles are put in close proximity, then you see color. If you spread them out, you don't. So essentially, a lateral flow device is an exercise in concentrating gold nanoparticles in the presence of your antigen of interest. Right? Antibodies, you just apply them and they passively immobilize. Aptamers, you apply them and they wash away.
Okay.
So that was the technical hurdle why it hasn't been done. And so the focus for our company has been developing techniques of immobilizing aptamers on nitrocellulose. And so that has been the work that we've been doing. Well, the first piece of the work we did was do aptamers work or not. They work, we got those beautiful dose response curves. We made an Ebola lateral flow device prototype using aptamers. If you increase the amount of Ebola you're adding in the sample, the signal becomes brighter, beautiful, beautiful. Everyone's happy, happy, happy. But the question still remains, how do you mobilize those aptamers on nitrocellulose? And so that's what our focus has been. And we've got a technology that we've patented, and we are going to continue developing that technology. We want to then use that to develop a modular configurable platform. What we mean by that is we think of the work that we do as Legos, you know the game?
Yes.
So essentially, we make the base Lego, and that's disease agnostic. So this is the base Lego. This is coming in very handy today. This is the base Lego and it's disease agnostic, right?
Yeah.
Lego, this is this one. And if it's for COVID and you put it on, it becomes a COVID test. If it's for Ebola, it becomes an Ebola test. If it's for flu, a flu test.
Okay.
So essentially, you're making a platform that allows you to quickly develop a lateral flow device. So that's time, that's money. To answer your question, the question you asked me was, what are the diagnostics we've made to completion? We have not yet made any diagnostics to completion. The second question that I am answering, which I asked myself, is, so what have we been doing as a company? And what we've been doing is building a platform that allows us to make lateral flow devices using aptamers. What is the significant technical challenge we have had to overcome? is the question of how do you make a 60 base pair in single-stranded nucleic acid stick on nitrocellulose. That's the focus of our work.
Perfect. I'm curious about your award. Hutano Diagnostics won the 2019 GE European Wattman Diagnostics Competition. When I hear Wattman, I think nitrocellulose.
Yeah, definitely.
Did that tell us the story behind that? What did you do and what earned you that award?